In this video, I will do example 5 of a related rate word problem. So in example 5, a sand and a gravel plant, sand is falling off a conveyor and onto a conical pile at a rate of 10 cubic feet per minute. The diameter of the base of the cone is approximately 3 times the altitude. At what rate is the height of the pile changing when it is 15 feet high? So how would I describe this? I guess you could pretend you're like in a beach and you, okay, so pretend you're in a beach and you picked up some sand, right? Or use your bucket, pick up some sand, and then you put that sand on the beach. It somehow forms a kind of like a dirt pyramid, right? I mean, not dirt, a sand pyramid. So when you pile up that sand on the ground, it forms a cone effect. So it's the same thing with this scenario. We have a gravel plant. Right? You have this gravel plant and it's picking up dirt, or I mean sand, and it's putting it on the ground and it forms some kind of cone. This is not a cone, it's a triangle. It forms a cone like this. And here's the radius, and then here is the diameter. Okay, so yeah, it forms a cone. So, okay, so sand gravel plant, sand is falling on a conveyor into a conical pile at a rate of, so it says at a rate of 10 cubic feet per minute. So that is a speed, and notice it says cubic, so that means we're dealing with the volume. So we have a cone, so we have to find, we're dealing with volume. So what is the volume of cone? So volume of a cone is V equals pi r square times h all over 3. Okay, so that is the volume of a cone, and they tell us that the speed or the rate is 10 cubic feet per minute. So that means our dv dt is 10 feet cubed per minute. Okay. What else did they tell us? They tell us that the diameter of the base of the cone is approximately, the diameter of the base of the cone is approximately 3 times the altitude. At what rate is the height of that pile changing when it is 15 feet high? So that means our height is 15. So our height is 15 feet, and our diameter is 3 times the height. And what are we trying to find? We are trying to find at what rate. So we got to find speed. In our case, it would be dv dt. Okay, so that is what we have to find. What else do we know? So if you look at our volume of a cone, we have 1, 2, 3. We have 3 variables, right? Right? V is a variable, R is a variable, H is a variable. We have 3 variables. But we only have one speed, right? Or one rate. Shouldn't we have 2 rates? No. So we don't have 2 rates. So what we're going to do is we're kind of going to substitute one of the variables for, yeah, we're going to substitute one of our variables for what we have. So what should we substitute? Well, I'm trying to think. Maybe we should substitute our radius. So we know that diameter is 3 times h, and the radius is so the radius is 2 times the radius. So wait, diameter is 3 times h. So what would be the radius? Half of that, right? So if the diameter is 3 times h, the radius is half of 3 times h. So that would be 3h over 2. Or yeah, 3 half h. So that's what I'm going to do. I'm going to substitute my radius. Why would I do that? Well, when you put in sand, what happens is the height, when you add more sand to this cone, what changes? The height, right? So the height isn't going to be constant. It's the radius. I mean, the radius is still stays the same. So when you put more sand, it just gets a little bit taller. So that's why I didn't substitute my height. Okay, so now I'm going to rewrite this as v equals 1/3 pi. And then I'm going to replace my r with 3 half h parentheses square times it by h. Okay. Then what I'm going to do is kind of clean this up. It's 1/3 pi. And then 3 half h square is 9h square over 4, right? 3h square is 9h square, and then you square the 2, so that's 4, and then times it by h. And then I guess what I would do is continue cleaning it up. So this would be 1/3 pi, and then this is 9h squared times h is 9h cubed over 4. And then maybe I will clean it up before I take the derivative. So the numerator would be 1 times pi times 9h cubed, which is really 9 pi h cubed. And then on the bottom, it's 12. Okay. And then now I will take the derivative implicitly in respect to time. So start with the left. What is the derivative of 1v in respect to time? Well, I know the derivative of just regular v is 1. And then in respect to time, you do have to add the dv dt. Okay, over here, what is the derivative of this whole thing? Well, I know pi is a constant, so you just have to apply power rule. So 3 times 9/12. Well, I know that 9 times 3 is 27, and the 12 stays the same. And then the pi stays the same as well. And then power rule, so old power minus 1, so it would be h. Old power minus 1, 3 minus 1 is 2. And then in respect to time, you do have to add the dh dt. Okay, so if we go back to our problem, what are we trying to solve? We are trying to solve for dv dt, and we have dh dt, and we said our height is 15 feet. So wait, are we trying dv dt? No, we're trying to, I take that back. We're not trying to find dv dt, we're trying to solve for dh dt. Because we already have dv dt, so yeah, that's what we're trying to find, dh dt. So how would I just see this dh dt, I want to get rid of this. How would I do so? Well, I can multiply both sides by the reciprocal. Wait, before I do that, let's see if 27 over 12 can be reduced. it can be. So it can be reduced to 3. So 27 divided by 3 is 9 by h squared. And then 12 can be reduced by 3. So that would be, oops, wait, 27 divided by 3 is 9. And then 12 divided by 4 is, or 12 divided by 3 is 4. So we're dividing everything by 3. So that would be 12. And then this would be still dh dt. And then over here you have 1 dv dt. Okay, so your goal is to solve for dh dt. How would I do this? Well, I could get rid of this whole thing, 9 pi h squared over 12, by multiplying both sides by the reciprocal of this. So what's the reciprocal of 9 pi h squared over 12? It would be 12 over 12 over 9 pi h squared. Okay. So 12 times 1 dv, that's 12. And then this would be 9 pi h squared. And then you'll have dv dt. And then over here, this cancels, which is what we want. And we're left with dh dt. And then let's just plug in our known values. So we have 12, 9 pi, and then our height was 15, right? So 15 or 15 feet, right? Be careful. We have to have our units. So if it's h squared, that would be, what is 15 squared? 225. So this would be 225, and then our units was height, but we have to square it. So this would be height square, feet square. Okay, and times this by dv dt. What was our speed? Our known speed was 10 feet cubed per minute. So I gotta be a bit careful with the units. So 10 feet cubed per minute. Okay. That gives you dh dt. Okay, kind of clean this up. So 12 times 10 is 120. 120 feet cubed. And then on the bottom, I know that 225 times 9 is 2025. So 225 times 9 is 225 times it by pi. And then on the top, it was feet cubed. And then on the bottom, we had a feet square. And then we also had the minutes on the bottom, right? Because, yeah. So 120 and 225 can be reduced. It would be 40 over 225. I think I messed up on the calculation. What did I mess up on? Mhm. Yeah, I think I messed up. Let's see. Uh, yeah, so I think if you reduce, I think I did it right. When you reduce and you do all the work, the top should be 8, and then the bottom would be 405 pi. Okay, and then what would be our units? Well, we have a feet cube here and a feet square. Well, feet cube over feet square cancels, it just becomes feet, and then you're still left with a minute. So your final answer is going to be dH dt equals to 8 over 405 pi. And then feet cube over feet squared, that just becomes feet, and that becomes on the top. And then on the bottom, it would be minute. Okay, so that's dH dt, and that's your final answer. That's our speed. That's basically what we want. Uh, yeah. Okay. So the other example will be a conical problem as well. So what made this problem more challenging than the other related rates is we had 3 variables in one rate. So what we kind of had to do is substitute one of our variables, and we substitute our radius because when you when you plug in more sand into this cone, that's the only thing that kind of stays constant. So the height does not stay constant. That's why I didn't use the height as one of my, I didn't substitute my height for one of my variables because it's not constant. It's going to get higher. Okay, so I'm going to stop here.